Okay, so we looked at direct proportion, which is the first thing to look at whenever you're looking at proportionality. So just to remind ourselves that if x is proportional to y or directly proportional to y, basically it means the same thing. Then when y doubles, so does x. When y triples, so does x. Or if we could say when y halves, so does x. And the other way around, when x doubles, y doubles, and so on and so forth. So, and we have a look at this table, we can see how if it goes up in twos, but also it started at 2, and this one goes up in 5s, and it starts at 5, then I suppose you could actually, even if you erased the 5 and the 2, then at the beginning, then it would still actually work. So, but the point is, so yeah, it just basically, if it follows this, then it this top one here, then it's directly proportional. And also, if it follows the bottom one, it's directly proportional. So if it followed the bottom one, we can see that if we plotted it on a graph, it would go through the origin. It would be a straight line that goes through the origin. Whenever we do say that one thing is proportional to another, we could write it like this, by the way. And you could say that x is equal to some constant multiplied by y. So if x is directly proportional to y, then x is equal to some mystery constant, whatever that could be, 3, 5, 2.9, anything. We don't know what it is, but it's equal to that constant value number multiplied by y. Or if you wanted to say it the other way around, say y is equal to some constant, that would be a different constant in this case, multiplied by x. So when we looked at some examples of that, these are just very standard kinds of questions. So they're telling us that A is directly proportional to B. So if A is 12, then B is 3. And we can say, therefore, now normally you would say A is equal to K times B, but we've done B times K, which is just the same thing, only because then we can change the B into a number by what we did is we changed A and B into numbers because we were given the values, and then we rearranged to find K, and then we put K back into the equation, and then we've got an equation for A in terms of B. And then we also asked to find what is A when B is 5, what is B when A is 36. The last bit we had to rearrange the equation. So these ones, questions 1, 2, 3, 4, are all to do with direct proportion. And then we're going to look at this thing called inverse proportion. And we're going to look at more complicated situations like this. So let's look at, I won't do those questions. We will do some ourselves over here. So we'll start off with inverse proportion. So the fact that inverse proportion has its special name, inverse proportion, makes it sound somehow, in some sense, special, and it causes people a lot of trouble. There are more proportional relationships that we're going to look at in this video, aside from inverse proportion, which people actually generally don't find that confusing, but they still find inverse proportion confusing. And I think it's just because of the fact that they've been given this special title. But what does inverse proportion mean? Well, it just means that it's the same. So let's say that if x, hang on a second. If the hell that happened? If x is inversely rather than directly, inversely proportional to y, well, that's the same as saying. In fact, maybe it'd be better if I write it as a formula underneath. So the way that we would write that is we'd say that x, and then we have the proportional symbol. Instead of writing y, that would mean x is directly proportional to y. I do 1 divided by y. So what that means is that if x is inversely, well, hang on, it's just zoom me right out. Where are we? Right, let me try that again. If x is inversely proportional to y, then that means that, well, it means the thing below, but let's write it out. X is directly proportional to 1 divided by y. So this is what inversely proportional really means. It's directly proportional to 1 divided by y. Let's do that. And that is the way it's written. There's no other. This symbol here means directly proportional. There's no other symbol that means inversely proportional. Inverse proportional just means this. So, but it does have an interesting characteristic. So if x is inversely proportional to y, or in other words, if x is directly proportional to 1 over y, then we can do the same thing as before with a little twist. Before, let's just recap what we would do if it was directly proportional. So if x was directly proportional to y, then we could write that x is equal to some constant multiplied by y. In this case, we say, maybe I'll do this on a different colour. So in this case, we'll say that x is equal to some constant multiplied by 1 over y. Okay? Which could just be rewritten as k over y. So if x is inversely proportional to y, then x is equal to the constant divided by y. Again, these are different constants. They're just a standard symbol for a constant, as in a value that doesn't change a number. So this time, if we want to rearrange to find out what k is, then we would multiply both sides by y, and we got k is equal to x multiplied by y. So for example, let's say that x is equal to 5 and y is equal to 2, and we're saying that x is inversely proportional to y. What's the equation that relates to 2? Well, using all of this here, we can see that k is equal to x times y, so k is just going to equal to 10. So, and this is if x is equal to k over y, so this is for x is directly inversely proportional to y. So we're saying, therefore, that x is the equation that relates x to y is 10 over y. X is 10 over y. Because that's the constant. That's what k is. So if they followed up and said, well, what is x when y is, let's say, 4? Well, we're going to just use the equation. X is equal to 10 over 4. 10 over 4 is 2.5. Okay, so this is how you would answer that. Now, one of the things I want you to notice here is that what I've done is I've doubled y, and what happened to x? It halved. So this is the other thing that we can say about inverse proportion. So if x doubles, y halves. Now, the other thing about inverse proportion is that it works both ways, in the same way as direct proportion works both ways. So, if x is inversely proportional to y, then y is also inversely proportional to x. So it would be the same the other way around. So if y doubles, then x would half, or if x doubles, then y would half. So that's the kind of thing that we do in inverse proportion. Now I think we're going to just, before I look at the other types of proportionality examples, we'll just focus on some questions on this first. Okay, so I will stop the video there.